Okay, so the second part of this lesson is going to look at how to write linear equations from word problems. And so this has a tendency to trip some people up just because you're not sure what information the problem's actually giving you. That's what I generally see with this kind of thing. So when you're reading a word problem, you want to look for two things first. You want to look to see if that problem is telling you the slope and the y-intercept. If it is, that makes your job really, really easy because all you're worried about is figuring out what the m and the b are so you can write this linear equation. So if it tells you the slope and the y-intercept, you're going to use those. The way we'll recognize that is for slope, you're going to look for words like each or per to find the slope. So if it tells you it's going to be, they're getting paid $10 per hour, or for each hot dog they sell, they earn $2.50. Words like that tell you that that's going to be your slope. Words like start or fee are words that indicate your y-intercept. Y-intercepts are like initial values. It's what you'd have to pay or what you would have if there was no change at all. So whatever it starts at, or whatever the fee value is, the thing that only happens once, is your y-intercept. If you can't pick out either of those things in the problem, then you can look for values that represent points. So that's going to look like two things with two different units being put together to represent the situation. So if it says something like, in 14 hours, he biked, 550 miles. I don't even know if that's reasonable. Probably not. Anyway, but something like that where you have two different units together, that can represent a point. Now, once in a while, you'll have a problem that gives you what looks like two slopes or two rates. They're not actually slopes, but it'll feel like they are because you'll have two different things that use each and per. Those equations have to be written in something called standard form. And standard form looks like your x and y on the same side. So we call that ax plus by equals c. But that's a situation like you have apples are $2.50 each and oranges are $1.99 each. And you have the word each in there twice, one for apples and one for oranges. And you spend a total of, $25 on fruit. A situation like that where this c is a total. And both of these have the word each or per. And so we write something in standard form for that. We're not going to do a whole lot of that in this unit. We'll do a lot in the next unit that we come to, but I do want you to know that that can exist. So be aware of that. So let's look at some examples of this. Mr. Mole left his burrow that lies below the ground and started digging his way at a constant rate deeper into the ground. After 5 minutes of descending at a rate of 1.8 meters per minute, he was 13.5 meters below the ground. Let y represent his altitude in meters relative to the ground after x minutes. So we know x is going to be minutes, y is going to be his height or his altitude, which means our slope has to be his altitude per his minutes or his meters per minute. That's going to be my slope. And I know that because that's what I would get if I divided the y by the x. So when I'm looking to figure out my m and my b so I can write this equation, the m is going to be that how many meters per minute he is digging. And it tells us here he's descending at a rate, we even have the word rate, which helps us pick out our slope, of 1.8 meters per minute. So that 1.8 is going to be my slope. Now, the fact that it says he's descending at 1.8 means it needs to be negative, because that means he's going down. So there's my m. Then I've got to be able to find b. b, remember, is what he started at. And so it tells us that he started at his burrow, and he started digging his way down. But it doesn't tell us where his burrow is, other than that it's below the ground. So we don't know the b. So if I don't know b, I need to see if I know a point, because the only other way I can find b if I know the slope is to have a point. So look at the information it gives us. It tells us that after 5 minutes, he is 13.5 meters below the ground. That can be put into a point. 5 is my x, 13.5 is my y. And I know that because it told me x should be minutes, so the 5 has to go for minutes. And so I can solve for b just like we did in earlier problems where we knew a slope and a point, but we had to find the b value. And so we do that using y equals mx plus b. And so in place of y, I'll put 13.5. In place of m, I'll put negative 1.8. I didn't mean to do that. Negative 1.8. In place of x, I'll put 5. And I'm going to leave b. And so I'm just going to do the math on that, calculate, see what we get. So I'll do negative 1.8 times 5 to start with. And I get 9, or negative 9. Bring down my 13.5. And so from here, all I have to do is get rid of this 9. So I add 9. Okay, I was like, why is this not coming out to be negative? And it should have been, he was 13.5 meters below the ground. That should be negative 13.5. All right, that's better. So if I add 9 to that, I get negative 4.5. And that makes sense because he's below the ground, but not as deep as he was 5 minutes later because he burrows down. So he starts at negative 4.5 meters, and he's burrowing down at 1.8 meters per minute. So if they are per second, meters per minute. Okay, minute. So if they ask us to write the equation of this, it's negative 1.8x minus 4.5. My m and my b. And again, that tells us that he started at negative 4.5 meters under the ground, and he burrowed negative 1.8 meters every minute. All right, let's look at another one. The cost of admission to a popular music concert was $10 for each child ticket and $14 for each adult ticket. If Jake's family spent $122 on tickets, how many children and adults could have gone to the concert? Write an equation letting X represent children and Y represent adult tickets. So if X is children's tickets and Y is adults tickets, and here we have the information for adult tickets right there, then we can put this together with the idea that they spent a total of $122 by putting equals 122. And then this is going to be one of those situations where I've got to write this equation in standard form. And the reason I know I have to do that is because I have what we consider to be two rates. $10 for each child ticket, $14 for each adult ticket. I have two different rates. So I can do 10 per child plus 14 per adult to give us a total of $122. That's a standard form equation. And we don't have to do anything else to that. That's just it. We don't have to find the m and a b to write an equation in standard form. Now, if we wanted to be able to tell the slope of this, we would have to rearrange it into slope-intercept form. But for now, we don't. So that's just it. All right, next. This one says Josh is an airline pilot. As he approaches his destination, he begins his descent. Now, descent means he's going to be landing the plane, going down. The airplane, which is 30,000 feet above the ground, begins descending at a rate of 2,000 feet per minute. Write a linear equation that represents the height of the airplane over time in minutes. So, again, if we're doing a linear equation for height, that means we're going to need an m and a b because it's going to be in slope-intercept form because we don't know the height. There's not a total here. So if I think about my slope, remember, slope is your rate, and it tells us up here that it's descending at a rate of 2,000 feet per minute. So if it's descending at that rate, that means my rate of change or my slope is decreasing, so negative 2,000 feet every minute. Now, the B, remember, is your starting value. Do we know where the plane started before it started descending? Now, obviously, the plane started on the ground at some point, and then it flew into the air, and it was in the air for a while, and then it started to come back down. But since this is a function of the change based on its descent, we need to know where it was when it started descending. And so it tells us that he was 30,000 feet above the ground when he began his descent. So our B can be 30,000. Because that's where he was before he started falling. So the equation for this, negative 2,000x plus 30,000. from 30,000 feet, he began descending 2,000 feet per minute. All right, take a look at this next one. Michaela received $100 for a birthday present. Oops. She then deposited it in a savings account. Each week thereafter, she added $5 to the account, but no interest is earned. The amount in the account is a function of the number of weeks that have passed. Write an equation to represent the amount of money, y, based on the number of weeks, x. So when I read this, she got $100 for her birthday, and then she deposited it in an account. And each week after that, she added $5. So when I think about writing an equation in slope-intercept form, because we have to write one for the total in the account, so it has to be y equals. My m has to represent how much it's changing. And so when we look at this, she starts with $100 and she changes it every week by adding $5. So my 5 has to be my slope. The 100 that she started her account with is my y-intercept. And there's my equation in slope-intercept form. All right, let's look at this one. Jaden is spending money at the average rate of $3 per day. Let's start with that. Spending money $3 a day. After 14 days, he has $68 left. Write an equation to represent the amount of money left in his account based on the number of days that have passed. Assume he does not add any money to his account during this time. So this one tells us that he's spending money at $3 per day. That's my slope. It says rate. We know that's the slope. Since he's spending it, it's decreasing by 3. But it never tells me how much money he started the account with. It tells us that in 14 days he's got $68 left, but it does not tell us where he started. But I can use that 14 days and $68 as a point, and I can solve for B. Oops. So remember, we do that using the y equals mx plus b equation. When we did this in class, we had some folks that had some other ways of coming up with this, and there are other ways you could have done it. But if I do this, I get negative 42. And so I can just turn around and add 42 to both sides. And I find out that he started with $110. So my equation is negative 3x plus 110. Now, some folks in class, when we did this in class, said, well, if 14 days have gone by and he spent $3 a day, I can just do 3 times 14 to figure out how much he's already spent and add that back to your 68. You absolutely can do that. 3 times 14 is 42. 68 plus 42 still gives you 110. So you still find the same y-intercept. If that makes sense to you, by all means, do that. But I need you to be able to recognize that a negative 3 is your slope and that he started with $110. All right. Kagan and Haley take a mission trip overseas. While there, Kagan calls her grandmother and talks to her for 5 minutes. That phone call costs her $5.91. Oops, wrong thing. And then we have Haley, who calls her brother and talks to him for 10 minutes. That call costs $10.86. And we're supposed to write a linear equation for the cost of a phone call based on time spent talking. So it's got to be a linear equation that represents the cost, which means it's going to be a y equals equation because it represents a total. X has to be time because they tell us the cost based on time. So that means I've got to figure out an m and a b to fill into this equation. So this problem does not tell me anything about each. It tells me that she talked for 5 minutes for $5.91 and that she talked for 10 minutes for $10.86. That is not a slope. None of that says each or per. None of it tells us what the bill started out as. It just tells us how much it costs for these 2 different times. That means it's giving us 2 points, 5 and 591 and 10 and 1086. So if we're given 2 points, we're going to have to solve for m and for b. So we can use slope formula to solve for m. And if I calculate that, and again, you can put that in your calculator, you can do the top and the bottom and then simplify. Either way, you get 0.99. So that means my slope is 0.99. Now to find your b, I'm going to give myself some space here. I would take that slope and then I would sub in an x and a y. So either one of these points, whichever one you're comfortable with. I'm going to use the 10 and the 1086 because I can multiply by 10 pretty easily. And then you solve that. So 0.99 times 10 is 9.9. And you can subtract 9.9. And you get 0.96. So our b value is 0.96. All right, a couple more. This one's very similar to the last one. And if you feel like you want to try one on your own, you could stop the video right here and try this one. But if you don't think you're quite ready yet, this is kind of a complicated deal. If you don't think you're quite ready, that's okay. But this one says, Bryson's completing a scientific study of crickets. In his study, he found that the number of chirps some crickets make per minute is related to temperature. The relationship is very close to being linear. In his study, he determined that when crickets chirp 124 times a minute, it's about 68 degrees Fahrenheit. When they chirp 172 times a minute, it's about 80 degrees Fahrenheit. So if we're going to represent this scenario in a function, we basically have 2 points that are given to us. We know that 124 times a minute means it's about 68 degrees, and 172 times a minute means it's about 80 degrees. So the only way I can write a function for this is to find my m and my b using my slope formula and then solving for b from there. So we'll do that first. So y minus y over x minus x. And that's going to give me, I don't remember what this comes out to be. 172. 12 over 48, which is 1 over 4. So I get 1/4 for my slope. And then for b, I'm going to have to solve for that using my 1/4 and one of those 2 points. So I'm just going to use 172, 1/4, and 80. And so that gives me oh, look what I did there, y'all. That was dumb. I put the X and the Y in the wrong spot. Just kidding. Most common mistake. Even I made it. All right, going back. X would be the 172. The Y would be 80. All right, that's better. So if I do that, I was like, why is the math on this that easy? This comes out to be 43. And then we'll subtract 43. And that gives me 37, which is what it was supposed to be. So my b is 37. So if my slope is 1/4 and my b is 37, my equation would be 1/4 x plus 37. All right, one more. TJ plans to diet to gain 0.25 pounds a day. After 14 days, he weighs 145 pounds. The number of days and his weight are related. or the number of days he diets in his weight. Write a linear function that represents his weight based on the number of days since he began his diet. So since we're representing his total weight, we got a y equals equation going on here. And so what we know is that he gains 0.25 pounds a day. This is our slope. This is how much it's changing. Since he's gaining, it'll be positive, so 0.25 goes with my x. My m is 0.25. Now, it does not tell us how much he weighs when he starts his diet, but we know that in 14 days, he weighs 145 pounds. So I can use that and my slope to find my b. So I'd get 145 equals 0.25 times 14 plus b. So multiply that and I get 3.5 plus b. And I can subtract 3.5. And so I get a b of 141.5. And that would be my equation. All right, that's the end of that lesson. Y'all have a beautiful day.